Hello students, welcome to the first lecture on thermodynamics. From this lecture onwards, we are going to discuss different aspects of thermodynamics in your class 11 chemistry chapter. This will be the first lecture, and in this lecture we will going to discuss the introductory of this thermodynamics, that is many basics things that we need to first understand to clear the concept in the later part. Okay, so today's lecture is basically is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Chemical energy which is stored in the molecules can be released as a heat energy when we burn methane gas or cooking gas or coal. Or there is another transformation, as for example in steam engine. Here also you will find the chemical energy has been converted into mechanical energy when we burn the fuel in the steam engine. And likewise in the galvanic cell also you can see that is the chemical energy which will be going to be converted into the light energy. So this energy has been transformed from the one form to the another form, that is chemical to mechanical, chemical to light, chemical to heat energy. So there is a lot of transformation that we are observing. And these energy transformations that is taking part from one part to the another, that is for the study matter of the thermodynamics. So in thermodynamics we are going to understand, going to calculate, measure the energy changes. It will concern about the initial and the final state of the system. And from this initial and final state, it will able to calculate the energy changes. But it is not concerned how the energy has been changed. That is from the chemical energy to the heat energy. What about the reactions? It will not concern about all those reactions. It will only concern about the macroscopic aspect of the systems by taking care of the initial state and the final state. And neither it will concern about the rate of the changes, how the energy has been changed, it is fast or it is slow. That is also not being taken care of by the thermodynamics. It will only be taken care of the first initial state and the final state of the system. And another thing that we need to understand, that when we are trying to measuring all the energy changes, we need some parameters, some properties of the system, and that property must be in the thermodynamics equilibrium. Thermodynamics equilibrium consists of the three things. That is number one, that we call about the thermodynamics equilibrium. Thermodynamics equilibrium is basically consists of three equilibrium. Three equilibrium that we will see, that will simultaneously be at the same time, that you will see, that is the thermal equilibrium, in the thermal equilibrium the temperature change will be 0. The temperature will be fixed for the systems, number one. Second is mechanical equilibrium, and third is chemical equilibrium. The three equilibrium will be present in the system simultaneously, and that will help us to measure the parameters which is necessary for us to understand or to measure the changes in the energy. So these three things that we need to understand. And in the thermodynamics chapter, in this chapter, what we are going to do, we are concerned about the changes of energy, changes of energy in the chemical reaction. We will going to changes the energy in the chemical reactions or process. As for example, I am giving you that we want to know how much energy has been changes, how much heat has been changes, how internal energy is changes when we boil 1 mole of water. How much energy is flow there? What is the work done? That we are going to discuss. This is chemical. In the chemical reaction, suppose there is a beaker and it has been the H2SO4 and you put some zinc species, and how much energy has been evolved in terms of your generation of the gas and generation of the heat, and that is going to be understood in the thermodynamics chapter. So two things, that is chemical reaction and the process, how the energy changes has been done. But before going for the calculations, going for measurement of the energy system, what we need a very important, some important thermodynamics terms. So now we are going to discuss some thermodynamics term. Thermodynamics term. First, we will discuss the most important thing, that you have to be frequently you will take the term, that is system. What is the system? System is basically the part of the universe where we are taking the observation. That is, it will say part of the universe. This is part of universe. System is part of universe, taking care of taking the observation. This is system. And another thing, that is surroundings. What is surroundings? Surroundings is it is also the part of the universe apart from this system. So part of the universe, we can say part of universe besides the system. As for example, so we can write one thing, universe is systems plus surroundings. Universe is basically the system plus surroundings. But when we are talking about a system, as for example, suppose this is a beaker. In this beaker there is sulfuric acid, any chemicals, reaction is going on, and it has been kept in this room. Suppose in this room is kept. So what is going to happen? This will create a system. This is a system, and around the system, the space of the universe, that will be the surroundings. But whole of the universe will not going to be affected by this system. That part of this universe which is going to be affected by this system, we will call that is the surroundings. Okay, I think it is understood that what is system? It is part of the universe taking the observations. As for example, this a beaker is kept here where we are taking the observation, or there is some reaction is going on, and the surrounding part, that is, suppose this is room where the beaker is being kept, is the surroundings, and between the system and the surroundings there is a separation point. There is a separation point. This separation point is called the boundary. So three things we will understand: boundary, surroundings and system. Boundary is basically necessary to understand the flow of matter and flow of the energy. You can observe that the system is having the two very important part, that is system. System is having, again when talking about a system, it is having number one, matter, and number two, that is very important, that is the energy. Energy may be different forms. So matter and the energy. So to track these all the things, matter and the energy, we have some boundary, some separation point, separation area, separation lines between these systems and the surroundings. This is called the boundary. And there is also a classification of the systems that we are going to understand. That basically, if we classify the system, that has been in the three ways. Number one classification, that is the open system. Open system. Number two, that is the closed system. And number three, that is the isolated system. Three type of system we will need to understand. Open system, closed system and the isolated system. Now understand what is open system, and this system, classification of system, is basically on the basis of the moment of the mass, that is the matter, and the energy. When matter and energy both is being exchanged with the surroundings, system and surroundings are exchanging this matter and energy, we will call this is a open system. This is a open system. As for example, open system is, that is, you are carrying out some reaction in a beaker. Suppose this is a beaker. In this beaker there is two substances A and B, and it is being reacting. At that time what is going to happen? It will produce some gas or produce some energy, heat energy. Normally you can see that this heat energy will be flow to the surroundings. The gas will go to the surroundings. Then we will say this is open system. Very simple. Now another system that we will be talking about, that is the closed system. Closed system, as for example, some reaction is going on in a circular, it may be circular or another form that you can see in the circular, in another form that is going on, and it is having the wall that is thermally conducting, that it can able to conduct, it can able to flow the energy to the, in the different form, flow the energy in the different form, that's for example heat, to the surroundings. Then we will call is, it is a closed. So in this case what is going to happen? Energy will go to the surroundings. There will be exchange of energy in the closed system, exchange of energy with the surroundings, but mass will not be exchanged. So energy will be exchanged here. But mass will not exchange. Mass will be as it is. that is in the system itself. So energy will be exchanged with the surroundings and system, surrounding and system. Here in this case, both energy and both matter will be exchanged. And three types, another thing, another system that is isolated, that is, suppose you are keeping hot water in a thermoflask or in any insulated vessel. At that time, what is going to happen? Neither energy nor the mass will be go out of the system. It will remain in the system as it is. There will be no exchange. In the isolated system, there is no exchange. And this wall, you will find this wall is called adiabatic wall. And this is also isolated system, also called adiabatic system. Another name. That is no exchange of mass, very simple thing, mass or you can say matter. That is most important thing. This matter will say, this is a universal thing, matter. What is the difference between mass and matter? Matter is a substance. And mass and energy. Both the things, mass and energy, that will be remain in the system itself. There will be no exchange with the surroundings. That will call the isolated system. So we understand what is system, what is surroundings, what is boundary, and what is different type of systems. So I think that is very clear to you. Now we are going to discuss the very important thing in the thermodynamics, that is the work and energy. Work and energy that will be frequently been encountered, frequently been associated with it during the discussion. So let us understand what is work and what is heat. Okay? Two very important things, that is work and heat. What do we mean by work? That work is basically it is a form of energy. Work is a form of energy. Everything is energy. Similarly, work is a form of energy that flows from system to surroundings, from system to surroundings, and surrounding to the system. Surrounding to system. This is very, very important thing to understand. Later on will be. When the system to surroundings, this will call the work done by the system. Who is doing the work? Work done by the system. System is doing the work. System is doing the work. Work done by the system. And when surroundings to the system, this will call the work on the system. Work on the system. Two things very important to understand. Work done by the system, work done by the system, and another thing, work on the system. There is a two type of works that will be accounted with, that we have to know. One is mechanical work. What is mechanical work? That we know. Very simple thing. That is work here, the force into distance. Force into distance. As for example, I am talking about this in more clearly. Suppose there is every type of reaction, you will find that it will be accompanied with the generation of the heat or generation of the gases. When the gas has been generated, it will have the capability to do some work. And this work is called the mechanical work, or it is called the displacement work. And that has been, mechanical work has been quantified by this formula, that is force, how much force is there and how much distance is there. That will be that we will going to deduce in the latter part of these lectures. So mechanical work is a force into distance, and it is also called the PV, pressure volume work. Pressure volume work means that gas is expanding or gas is being compressed by a system called the piston, and it will going to be create some energy in the form of work. So this is mechanical work. And second thing, that is your electrical work. You are also being acquainted with the electrical work, and in the electrical work you will see the force is here. Force will be here, the EMF force, electromotive force. EMF force, EMF is a electromotive force, that is the EMF of the cell, and into the quantity of electric charge. Quantity of electric charge. So this will give the electrical work. So two types of work we understand. One is mechanical work and other is electrical work. Okay. Now another very important form of energy, that is heat. Heat is a very important form of energy that we are going to understand. It is basically heat is being transformed from the surroundings to the systems, or from the system to the surroundings, due to the temperature difference. The energy which flows from this system to surroundings, surrounding to systems, are basically the heat due to the difference in the temperature. Okay? So this is the heat and this all the energy. Now we are going to discuss the very important thing, that is what are the units of this work and units of the heat. Now we are going to discuss the units of work and heat. Work and heat. Heat is represented by Q and work is represented by W. Okay. So units of work. First let's understand the units of work. What are the units? First, in the CGS units, it is have the CGS unit. It is have arg, E-R-G-S. Arg means dyne in centimeter. Dyne centimeter is arg, and it has the SI unit. Another unit SI. This is joule. Joule is Newton meter. What is the relation between the arg and this joule? It is 1 joule is equal to 10 to the power 7 arg, and 1 kilojoule is equal to 1000 joule. This is very, very important to understand. Another units of the work, that is the liter atmosphere. Liter atmosphere. And the 1 liter atmosphere is 1 liter atmosphere. Atmosphere is equal to 101.3 joule. So liter atmosphere is the much more higher units than the joule. Okay. Now that is your work. Now we are going to the units of the heat. Units of heat is, it is represented by Q. The CGS units is calorie. CGS unit is calorie. SI units of the heat is your joule. The relation between joule and calorie is 1 calorie is equal to your 4.184 joule. Another units of the work, that is the electron volt. Electron volt is 1.6 into 10 to the power minus 19 joule. So these units will be required during the calculations, numericals. Different form of units will be given to you and you have to convert it this and from this. It is very important. That is, you understand CGS unit, arcs, SI unit, joule, and 1 joule equal to 10 to the power 7 arcs, 1 kilojoule 1000 joule, and another unit liter atmosphere. That liter atmosphere equal to 101.3 joule, and heat CGS is calorie, SI unit joule, and other things. Different type of process. This will be very important to understand. Different type of process. In this process, we will keep one parameter is constant. One properties is made constant. Property is constant. First, isothermal process. Isothermal process. In the isothermal process, T constant, del T is equal to 0. Isoporic process. In this, V constant, del V is equal to 0. Isobaric process. V constant means change of pressure is 0. Fourth is adiabatic process. In this case, Q is equal to 0. This is called adiabatic process. So different type of process we will understand. Another process that will be coming around, that is the cyclic process. Cyclic process, where it will, after several changes, the state functions will become the same. There is no change in the state functions. This is called the cyclic process. So all these process we will understand, and I think that will be end of this lecture. In this lecture, that we will discuss some fundamentals, and these fundamentals will be required in the next lectures to understand the concept, how we are able to calculate the energy, what is the basis of understanding the intended energy, then enthalpies, that are going to discuss with the different lectures. So that is all today's video. Hope you have enjoyed this video. If you like this video, you can share to your friends. Thank you very much for watching. Thank you.